a super high-energy, fast-paced explainer on an absolute foundation of physics, motion. If your grasp on this chapter feels a little, shaky, or you just need a rock-solid review before a big test, you are in exactly the right place. By the end of this explainer, we're going to cover 100% of the core concepts, the formulas, and the numericals, and we'll do it clearly and systematically. I can pretty much guarantee you're going to see these exact concepts pop up in your exams. But hey, before we really get into it, we need to set our intentions. In the original source for today's explainer, the instructor asks his students to make a hard mental commitment before learning. So I want you to take this rallying cry to heart right now. I will ace the exam. Say it to yourself. Commit to it. Are you ready? Okay, let's dive in. All right, so here is our roadmap for today. We have 6 quick stops: motion and rest, distance and displacement, speed, velocity, and acceleration, how to understand graphs, the 3 equations of motion, and finally, uniform circular motion. Let's kick things off right now with Section 1, motion and rest. Okay, so what does it actually mean to be moving versus, sitting completely still? Picture this. Imagine your crush is riding the bus to school. You're standing outside on the sidewalk with your bike, watching that bus go by. From your perspective, your crush is clearly moving, right? They are literally passing right before your eyes. But imagine your incredibly mischievous best friend happens to be sitting directly next to your crush inside that very same bus. To your friend, your crush is sitting completely still. The physical distance between them on the bus isn't changing at all. So who's right here? Are they moving or are they at rest?
So, the crazy thing is, you are both right. Motion is entirely relative. It depends completely on the observer. Motion and rest, they aren't absolute terms. They literally only make sense based on who is looking and from where they're looking. Moving right along to Section 2, distance and displacement.
So how do we actually measure the trip from point A to point B? Well, in physics, we have 2 completely different ways to measure travel: distance and displacement. Distance is just the length of the actual total path you covered. If you walk 5 meters right, 10 meters up, and then 10 meters left, your total distance is 25 meters. You literally just add up every single step you took. Displacement, though, that's a shortcut. It is the absolute shortest straight line from your initial starting point directly to your final ending point. In that same walking example, even though you walked 25 meters in total, the direct gap from where you started to where you ended up might only be 5 meters. So your distance is 25, but your displacement is just 5.
Think about how extreme this difference can get with this kinda dark but totally unforgettable example. Imagine you're born in a specific hospital room. You grow up, you travel the whole world, get married, have kids, and live this massive, wild, adventurous life. But at the very end of your long life, you pass away in the exact same hospital where you were born. Over your lifetime, you covered an immense distance, but mathematically speaking, because your initial starting point and your final ending point are the exact same location, your total life's displacement is 0. Absolutely 0. And that brings us to the core binary contrast between the two. Distance is what we call a scalar quantity, meaning it only has a magnitude, just a raw value. It's always positive, and it completely depends on the exact winding path you took. Displacement is a vector quantity. Vectors care about magnitude and direction. Because it cares about direction, displacement can be positive, negative, or even 0, like our hospital example. It literally only cares about the initial and final points and nothing in between.
All right, Section 3, speed, velocity, and acceleration. Now that we know how to measure where things are, let's talk about how fast an object changes its position over time. Just like distance and displacement are siblings, speed and velocity are siblings. Speed is simply distance divided by time. It has absolutely no direction. Velocity, on the other hand, is displacement divided by time. To put it simply, velocity is just speed with a specific direction attached to it. If you're backing up your car at 5 meters per second, your speed is 5, sure, but your velocity is -5 because you're moving in reverse. Oh, and real quick, here's a massive pro tip for your exams. If a test question gives you a speed in kilometers per hour, immediately multiply it by 5/18 to instantly convert it to meters per second.
But what happens when the velocity itself changes? Well, that is acceleration. It's the rate of change of velocity. The formula is just final velocity minus initial velocity, all divided by time. Now please notice the specific unit here. It is meters per second squared. Do not just write meters per second on your exam or you will throw away easy marks. Also, remember that if acceleration is working opposite to the direction of motion, it's going to be negative, which just means it's slowing the object down. Which leads us perfectly into uniform versus non-uniform motion. Uniform motion simply means traveling equal distances in equal amounts of time. Your speed is perfectly constant, and here's the ultimate trick question teachers love to throw at you. If your speed isn't changing, what is your acceleration? It's zero. Think about it. If velocity doesn't change, there's zero acceleration. Non-uniform motion, on the flip side, means covering unequal distances over the same time. The speed is changing, which means acceleration is absolutely not zero.
Okay, on to Section 4, how to understand graphs.
We're going to completely demystify visual data right now. If physics graphs intimidate you, don't sweat it. We are going to crack them wide open using one ridiculously simple mathematical trick. The secret to basically all motion graphs is the slope. And slope is literally just whatever is on the y-axis divided by whatever is on the x-axis. That's it, y divided by x. Also, visually speaking, the steeper the angle of the line, the greater the slope.
Let's apply that trick to these two core graph types. You'll want to take a mental screenshot of this. In a distance-time graph, divide the y-axis, which is distance, by the x-axis, which is time. What is distance over time? Speed. So boom, the slope gives you speed. In a velocity time graph, divide velocity by time. What is change in velocity over time? Acceleration. So the slope gives you acceleration. And if the line is straight and starts right from the origin, that means the slope is perfectly constant, meaning you have constant speed or constant acceleration, respectively.
Let's rapid fire through these visual rules so they stick. A constant straight line means uniform. A curved variable line means non-uniform. If a line is totally flat, completely parallel to the x-axis, its slope is zero. On a distance graph, zero slope means the object is just resting. On a velocity graph, it means the speed isn't changing. And the final, absolutely most crucial rule for your tests. If you ever need to find how far an object traveled on a velocity time graph, just calculate the geometric area under the line.
Next up, Section 5, the three equations of motion.
This is where it gets really interesting, because we get to tie all these variables together to literally predict the future of a moving object. Equation 1, v equals u plus at. Equation 2, s equals ut plus half at squared. And equation 3, v squared equals u squared plus 2as. The instructor from our source material actually jokes here that you should pause this explainer and swear on your crush to memorize these instantly. Honestly though, if you don't memorize these, someone else is going to walk away with your top grade.
Acing the exam with these equations is honestly just about extracting hidden data before you even touch the math. Let's look at this step-by-step example of a bus problem. Step 1, extract the data. If the problem casually says starts from rest, that is hidden code meaning your initial velocity, or u, is exactly 0. Step 2, convert your units. If it says 2 minutes, do not use the number 2. Convert that straight to 120 seconds. Step 3, once you have u, a, and t in the exact right units, you simply plug them into the first equation to find v. It really is that systematic.
And finally, Section 6, uniform circular motion.
Let's see what happens when an object travels in a perfect circle. Guys, here is the absolute biggest trap in the entire topic, uniform circular motion. Say an object, like a bird or a satellite, is flying in a perfect circle at a totally steady 10 meters per second. Its speed is completely constant. But because it is moving in a circle, its direction is changing at every single millimeter of the journey. And remember what we said earlier? Velocity is speed plus direction. Since the direction is constantly changing, the velocity is constantly changing. And if velocity is changing, that mathematically means the object is technically accelerating, even though its speed is dead constant. Please do not let that trick you on a test.
If you ever need to calculate the actual speed of an object moving in a circle, you just use this handy formula, 2 pi r divided by t. 2 pi r gives you the total circumference, which is just the distance of one complete circle, and you divide it by the time it took to do one single revolution. It's literally just our old friend distance over time, but in a circle. And that actually brings us to the end of this fast revision explainer. But wait, I'm not going to let you off the hook without a quick challenge. A bus starts from rest. It accelerates at 0.1 meters per second squared for exactly 120 seconds. Using the equations of motion we just locked into our brains, what is its final speed and what is the total distance it traveled? I want you to calculate the answers and drop them in the comments below to prove you are ready for exam day.
Keep learning, keep pushing yourselves, and I will catch you on the next explainer.